For centuries, humans have gazed up at the night sky, wondering if we are alone in the universe. This curiosity has fueled countless theories and imaginations about life beyond Earth, particularly within our own solar system. Today, we'll explore how our ancestors viewed the possibilities of alien life, the fascinating misconceptions they held, and how modern science has debunked these ideas. Our journey begins with ancient civilizations. Long before the age of telescopes, early astronomers in cultures like those of the Babylonians and Greeks observed the night sky with the naked eye. They noticed the wandering stars, which we now know as planets, moving against the backdrop of fixed stars. To these early sky watchers, the heavens were not just a collection of lights, but a celestial tapestry woven with stories and deities. The Babylonians, for instance, meticulously recorded the movements of celestial bodies on clay tablets. They saw the planets as gods walking across the sky, with Jupiter representing their chief god Marduk. Similarly, the ancient Greeks developed intricate mythologies around the planets. Venus was associated with Aphrodite, the goddess of love, while Mars represented Ares, the god of war. The Greek philosopher Pythagoras even speculated about the harmony of the spheres, suggesting that celestial bodies moved according to mathematical principles and produced a kind of cosmic music. These mythological interpretations were not mere flights of fancy, they were early attempts to explain the cosmos using the knowledge and beliefs of the time. However, these explanations were limited by the observational tools available. It wasn't until the invention of the telescope in the 17th century that our understanding of the cosmos began to take shape in a more scientific manner. In 1609, Italian scientist Galileo Galilei crafted his own telescope, which was far more powerful than any instrument before it. This marked the beginning of a new era in astronomy. Galileo's observations were revolutionary. He discovered the moons of Jupiter, the phases of Venus, and detailed the rough, mountainous surface of our moon, challenging the long-held belief in perfect, unchanging heavens. These groundbreaking observations laid the foundation for modern astronomy and shifted our perspective from mythological interpretations to empirical science. Galileo's work not only expanded our knowledge of the solar system but also inspired future generations to look beyond Earth in the quest for understanding and the search for extraterrestrial life. The Renaissance and the subsequent scientific revolution propelled humanity into a new age of discovery. Telescopes grew more sophisticated, and astronomers like Johannes Kepler and Isaac Newton furthered our understanding of planetary motion and gravity. This era of enlightenment fueled speculation about life on other planets, a theme that continues to captivate us to this day. In 1610, Galileo Galilei pointed his newly crafted telescope at the night sky and forever changed our understanding of the cosmos. This marked the dawn of modern astronomy. One of his most significant discoveries was the four largest moons of Jupiter, Io, Europa, Ganymede, and Callisto, now collectively known as the Galilean moons. These moons were the first celestial bodies observed to be orbiting another planet, providing concrete evidence that not everything revolves around the Earth. This discovery was pivotal in supporting the heliocentric model proposed by Copernicus, which posited that the planets, including Earth, orbit the Sun. Galileo's observations didn't stop there. He also observed the phases of Venus, similar to the phases of the Moon, which could only be explained if Venus orbited the Sun. This was another strong piece of evidence against the geocentric model, which had dominated for centuries. Additionally, Galileo studied the rugged surface of our Moon, noting its mountains and craters, which dispelled the notion of a perfect, unblemished celestial sphere. These discoveries were groundbreaking not only for their scientific implications but also for how they challenged established beliefs. The idea that celestial bodies could have features similar to Earth's, or that moons could orbit planets other than our own, opened up new possibilities. It suggested that other planets and moons might also be worlds in their own right, potentially harboring life. Galileo's findings ignited the imagination of both scientists and the public. If Jupiter had its own system of moons, could those moons be like mini-planets? Could they support life? This line of thinking extended to other planets. As telescopes became more powerful, astronomers began to speculate about the conditions on Mars, Venus, and beyond. Galileo's use of the telescope demonstrated the power of technology to enhance our understanding of the universe. His work laid the groundwork for future astronomers, such as Johannes Kepler and Isaac Newton, who built upon his discoveries to further unravel the mysteries of planetary motion and gravity. Kepler's laws of planetary motion and Newton's law of universal gravitation provided a comprehensive framework for understanding the movements of celestial bodies. These advancements marked the transition from philosophical speculation to rigorous scientific inquiry, setting the stage for the detailed exploration of our solar system. The legacy of Galileo's discoveries is profound. By challenging conventional wisdom and embracing empirical evidence, he helped usher in a new era of science. This spirit of inquiry and skepticism continues to drive our exploration of the cosmos. Today, as we send spacecraft to distant planets and moons, we build upon the foundation laid by Galileo and his contemporaries, ever seeking to answer the age-old question, are we alone in the universe? As telescopic technology advanced through the 17th and 18th centuries, our fascination with celestial bodies grew. By the 19th century, the focus shifted significantly towards our closest neighbor, the Moon. The Moon's proximity made it a prime candidate for speculation about extraterrestrial life. One of the prominent figures in lunar observation was Sir William Herschel, an accomplished astronomer who discovered Uranus and made detailed studies of the Moon. Herschel, like many of his contemporaries, speculated that the Moon's surface features, its craters, mountains, and plains, could harbor life. He hypothesized that these craters might be vast plains or even cities built by intelligent beings. In 1835, the Great Moon Hoax took this fascination to new heights. The New York Sun published a series of articles claiming that astronomer Sir John Herschel, William Herschel's son, had discovered life on the Moon using an advanced telescope. The articles described fantastic creatures like bat-winged humanoids, lush landscapes, and even temples. Although it was later revealed as a sensational fabrication, the hoax captivated the public and reflected the widespread hope and excitement about finding life beyond Earth. While the hoax was pure fiction, it highlighted the intense interest and optimism of the time. The Moon, with its familiar yet mysterious presence in our night sky, seemed the most likely place to find extraterrestrial neighbors. This era was characterized by a blend of scientific curiosity and imaginative speculation. However, scientific progress soon provided a clearer picture. In the mid-19th century, more detailed observations and improved telescopes revealed the Moon's true nature. It was a barren, airless world, with no signs of water or vegetation, key ingredients for life as we know it. By the early 20th century, the notion of life on the Moon had been largely abandoned by the scientific community. The harsh realities of the lunar environment, with its extreme temperatures and lack of atmosphere, made it clear that the Moon could not support life. Yet, this did not diminish our fascination with our celestial neighbor. Instead, it redirected our focus to other parts of the solar system. The Moon's role in human exploration took on a new dimension with the advent of space travel. The Apollo missions of the 1960s, culminating in the historic moon landing of Apollo 11 in 1969, allowed us to set foot on another world for the first time. These missions confirmed the Moon's lifeless state but provided invaluable insights into planetary science and the origins of our solar system. The journey to the Moon was not just a leap for humanity in terms of space exploration but also a humbling reminder of the vastness and complexity of our universe. It underscored the need for advanced technology and rigorous scientific methods in our search for extraterrestrial life. The Moon, once thought to be a potential home for otherworldly beings, became a stepping stone to the stars, fueling our quest to find life beyond our own planet. But it was Mars that truly ignited the imagination about extraterrestrial life in the late 19th and early 20th centuries. Mars, with its reddish hue and changing surface features, has long fascinated astronomers and the public alike. This fascination reached a fever pitch with the advent of telescopic observations. In 1877, Italian astronomer Giovanni Schiaparelli observed Mars through a telescope and reported seeing a network of linear features on its surface, which he called canali, meaning channels. However, this term was mistranslated into English as canals, implying artificial structures built by intelligent beings. This translation error sparked a wave of speculation and excitement. One of the most ardent supporters of the Martian canal theory was American astronomer Percival Lowell. Lowell was captivated by the idea of an advanced Martian civilization. He spent years meticulously mapping the Martian surface, documenting hundreds of canals. He believed these structures were evidence of a vast, planet-wide irrigation system designed to transport water from the polar ice caps to arid regions, suggesting a dying planet whose inhabitants were struggling to survive. Lowell's theories were widely publicized and captured the imagination of the public. His books, such as Mars and its Canals, and Mars as the Abode of Life, painted vivid pictures of a once thriving Martian society now clinging to survival. This narrative resonated deeply, influencing literature and culture. H.G. Wells' The War of the Worlds, published in 1898, famously depicted a Martian invasion of Earth, reflecting contemporary anxieties and fascination with Mars. However, as observational technology improved and more detailed studies were conducted, doubts about the canal theory began to emerge. In the early 20th century, astronomers like E.M. Antoniadi used larger and more sophisticated telescopes to study Mars. They found that the supposed canals were optical illusions, likely caused by the human brain's tendency to connect faint, indistinct features into linear patterns. The nail in the coffin for the canal theory came with the advent of space exploration. In the 1960s, NASA's Mariner missions provided the first close-up images of Mars, revealing a surface covered with craters, mountains, and valleys, but no canals. Mariner 4's flyby in 1965 and subsequent missions like Mariner 9, which orbited Mars in 1971, showed a world that was cold, dry, and barren, with no evidence of a Martian civilization. These discoveries marked a turning point in our understanding of Mars. The idea of a once lush planet with a thriving civilization gave way to the reality of a harsh, inhospitable environment. Despite this, Mars has remained a focal point for the search for life, albeit in microbial form. Recent missions have found evidence that liquid water once flowed on the Martian surface, and that subsurface water may still exist, keeping alive the possibility that Mars could have supported life in its distant past. The story of Mars and its canals is a testament to the power of human imagination and the importance of scientific rigor. While the canals turned out to be an illusion, the quest to understand Mars has led to incredible advancements in space exploration and planetary science, continually pushing the boundaries of what we know about our neighboring planet. Mars wasn't the only planet thought to harbor life. Venus, often called Earth's twin due to its similar size and proximity, also captured the imaginations of astronomers and scientists. In the early 20th century, Venus's thick cloud cover prevented detailed observations of its surface, leading to rampant speculation about what lay beneath. For decades, Venus was imagined as a verdant paradise, with dense jungles, vast oceans, and perhaps even advanced civilizations. This speculation was fueled by the belief that the planet's cloud cover could be water vapor, suggesting a warm, wet environment similar to Earth's tropics. Some scientists and writers envisioned Venus as a young Earth, teeming with life. These ideas were prominently featured in science fiction literature. Stories often depicted Venus as a lush, exotic world, home to various forms of life. Edgar Rice Burroughs' A Venus series, starting with Pirates of Venus in 1934, portrayed a planet filled with strange creatures and human-like societies. Such depictions fueled public imagination and the hope that we might find life on our planetary neighbor. However, as space exploration progressed, our view of Venus changed dramatically. The first hints of Venus's true nature came with the development of radio astronomy and radar mapping in the mid-20th century. These techniques revealed a much harsher environment than previously imagined. The reality of Venus's environment became undeniably clear with the arrival of space probes. In 1962, NASA's Mariner 2 spacecraft flew by Venus, providing the first direct measurements of the planet. The data indicated extremely high temperatures, refuting the idea of a temperate, life-friendly world. Subsequent missions by the Soviet Union, particularly the Venera series, painted an even bleaker picture. The Venera probes, designed to withstand the planet's extreme conditions, managed to send back data and images from the surface. These missions revealed that Venus has surface temperatures around 475 degrees Celsius, an atmospheric pressure 90 times that of Earth, and clouds of sulfuric acid. The surface is dry, rocky, and inhospitable. These findings shattered the illusion of Venus as a lush paradise. Instead, Venus emerged as one of the most hostile environments in the solar system, far removed from the life-supporting conditions once imagined. Despite its Earth-like size and proximity, Venus's extreme conditions make it an unlikely candidate for life as we know it. And more recent ones like Venus Express have provided valuable insights into planetary science, atmospheric dynamics, and the greenhouse effect. Understanding Venus's climate and geology helps us learn more about Earth's past, present, and future, and the complex factors that govern planetary environments. While Venus may not harbor life, its study continues to intrigue scientists. The lessons learned from Venus's extreme climate inform our understanding of exoplanets and the potential for habitability in distant solar systems. Venus, once thought to be an Eden, now serves as a stark reminder of the diverse and often extreme conditions that exist within our own solar system. As our understanding of the planets in our solar system grew, so did our approach to the search for extraterrestrial life. By the mid-20th century, the focus shifted from finding advanced civilizations to identifying conditions that could support microbial life. This shift was driven by advancements in technology and a better understanding of the requirements for life. In 1976, NASA's Viking missions to Mars marked a significant milestone. The Viking 1 and Viking 2 landers were equipped with experiments specifically designed to detect signs of microbial life in the Martian soil. Although the results were inconclusive and sparked considerable debate, the Viking missions paved the way for future exploration and more sophisticated life detection experiments. The search for life continued with missions to the outer planets and their moons. One of the most intriguing targets is Europa, one of Jupiter's largest moons. The Galileo spacecraft, which orbited Jupiter in the 1990s, provided compelling evidence that Europa harbors a subsurface ocean beneath its icy crust. This ocean, kept warm by tidal heating, could potentially support microbial life. Similarly, Saturn's moon Enceladus emerged as another promising candidate. In 2005, the Cassini spacecraft discovered water ice plumes erupting from Enceladus's south pole, indicating a subsurface ocean. These plumes contain organic molecules, hinting at the moon's potential to support life. These discoveries have shifted the focus from planets to moons in our quest to find extraterrestrial life. The idea that life could exist in the dark, hidden oceans of icy moons has expanded our understanding of where life might thrive. This has significant implications for the search for life beyond our solar system, suggesting that habitable environments could be more common than previously thought. Another exciting development in the search for extraterrestrial life is the study of exoplanets, planets orbiting stars outside our solar system. Since the first discovery of an exoplanet in 1992, thousands have been identified, with some located in the habitable zone of their parent stars, where conditions might be right for liquid water to exist. The Kepler Space Telescope, launched in 2009, revolutionized our understanding of exoplanets. Kepler's discoveries include Earth-sized planets in the habitable zones of their stars, raising the possibility that some of these worlds could host life. Current missions, like the Transiting Exoplanet Survey Satellite, TESS, and the James Webb Space Telescope, aim to further explore these distant worlds and analyze their atmospheres for biosignatures, indicators of life. In addition to these missions, the search for extraterrestrial intelligence, SETI, continues to scan the cosmos for signals from advanced civilizations. Using radio telescopes, SETI scientists listen for unusual transmissions that could indicate the presence of intelligent life. Although no definitive signals have been detected so far, the search continues with ever-improving technology and renewed enthusiasm. The modern search for extraterrestrial life is a testament to human curiosity and ingenuity. From robotic explorers on Mars to powerful space telescopes scanning distant stars, our quest to find life beyond Earth has evolved into a sophisticated, multidisciplinary effort. As we continue our journey through the history of the search for extraterrestrial life, it's essential to recognize the role of scientific skepticism and critical thinking in debunking myths and advancing our understanding. From the canals of Mars to the supposed civilizations on Venus, many early ideas were based on misinterpretations and speculative science. One of the most famous examples is the belief in Martian canals, which we discussed earlier. Despite the enthusiasm and detailed maps produced by Percival Lowell, further observations and the advent of space missions like Mariner 4 conclusively showed that these canals were optical illusions. This process of hypothesis, observation, and revision is a cornerstone of the scientific method. Similarly, the lush, Earth-like Venus of early 20th century imagination was debunked by direct measurements from space probes like Mariner 2 and the Soviet Venera missions. These missions revealed a planet with extreme surface temperatures and pressures, making it clear that Venus could not host life as we know it. These findings were critical in shaping our current understanding of planetary environments and the conditions required for life. In addition to planetary missions, the rise of astrobiology as a scientific discipline has played a crucial role in debunking myths and focusing the search for life on more plausible targets. Astrobiologists study the origins, evolution, and potential distribution of life in the universe, using a multidisciplinary approach that includes biology, chemistry, geology, and astronomy. One of the significant advancements in this field is the study of extremophiles, microorganisms that thrive in extreme environments on Earth, such as deep-sea hydrothermal vents, acidic hot springs, and the dry valleys of Antarctica. These discoveries have expanded our understanding of the possible habitats for life, suggesting that life could exist in similarly extreme conditions elsewhere in the solar system and beyond. The study of extremophiles has informed missions like NASA's Mars rovers, which search for signs of past or present microbial life in the planet's ancient lakebeds and subsurface. The discovery of ancient organic molecules by the Curiosity rover, and the identification of seasonal methane spikes in the Martian atmosphere, hint at the tantalizing possibility of microbial life beneath the Martian surface. Another exciting development is the study of biosignatures, which are chemical indicators of life. Missions like the upcoming Europa Clipper and the James Webb Space Telescope will search for these signatures in the atmospheres of exoplanets and the icy moons of our solar system. By identifying specific molecules, such as oxygen, methane, and water vapor, scientists hope to find indirect evidence of life. The scientific method's rigor, hypothesizing, testing, and revising, has been instrumental in debunking myths and refining our search for life. While many early ideas have been disproven, each discovery has brought us closer to understanding the true potential for life beyond Earth. It's a process that underscores the importance of skepticism, evidence, and continual inquiry in the pursuit of knowledge. In this ever-evolving field, we remain driven by curiosity and the desire to uncover the mysteries of the cosmos. The journey from myths to scientific discoveries highlights not only the progress we've made, but also the boundless possibilities that lie ahead. Each step forward brings us closer to answering one of humanity's most profound questions: are we alone in the universe?